Chapter 5, Exercise 5.76, Part A, determine whether each molecule is polar or nonpolar. In ClF5, chlorine pentafluoride, we have one lone pair and 5 ClF bonds. Because chlorine has 7 valence electrons, it uses 5 of them to form 5 single bonds, and then still you have a lone pair. I think it's polar because you can imagine the molecular geometry is square pyramidal with one lone pair on top and a fluorine atom on the bottom of chlorine. They do not cancel, the polarity do not cancel. SCl4, this is polar. This one adopts a seesaw structure because sulfur has 6 valence electrons. It uses only 4 valence electrons to form 4 sulfur chlorine single bonds. There's a lone pair, so this is a seesaw structure. The bond polarity does not cancel. IF5, this is similar to chlorine F5 because both chlorine and iodine have 7 valence electrons. They have the same electron geometry, they have the same molecular geometry. SEF2, this is a bent structure. This selenium has 6 valence electrons. It uses only 2 valence electrons to form 2 single bonds with the 2 fluorine atoms. What about the remaining 4 valence electrons? They form 2 lone pairs. So this is a bent structure. The molecular geometry is bent. The SEF bonds do not cancel, so this is polar as well. Let's see, SEF2, it's bent molecular geometry. The bond polarities do not cancel. These two are similar because iodine and chlorine, they both have 7 valence electrons. They both have a square pyramidal molecular geometry. The bond polarities do not cancel. Alright, this one is a seesaw. Why seesaw? Well, actually there are 5 electron groups surrounding sulfur. 1 is lone pair, the other 4 are sulfur chlorine bonds. 2 bonds point in exactly opposite direction. They do cancel, but then 2 other bonds point in different directions. The 2 other bonds form a roughly 120 degrees angle. Alright, not exactly 180, it's around 120, so they do not cancel. This molecule is